Okay, let's unpack this. You sent us this incredible magazine issue focused entirely on space exploration.
Yeah.
And diving into it feels particularly relevant right now. It seems timed with a pretty big anniversary.
It does. This source, it came out right around the 50th anniversary of Apollo 11, which, really sets the stage.
Ah, right.
It's kind of a perfect moment to reflect on how far we've come and, well, where we're headed 50 years after those first steps.
Absolutely. And what's great about this source, I think, is it doesn't just list missions, does it?
No, not at all.
It gets into the why, the science, the technology,
Yeah.
the inspiration, even the politics and the legal stuff, which is surprising.
Right. All the drivers behind venturing out there. So for this deep dive, our mission really is to synthesize all of that.
Okay.
We're going to try and pull out the most important insights this source offers, give you a clear picture of, solar system exploration today and tomorrow.
Sounds good.
We'll look at the destinations, the motivations, the big plans for the moon, for Mars, and also some of the real challenges and questions this new era brings up.
And use the details from the magazine to bring it to life.
Exactly. Let's make it vivid.
All right. So where does this source begin our cosmic tour?
It starts pretty close to home, actually, highlighting ongoing exploration across our cosmic neighborhood. First up, Mercury.
Mercury. Yeah, arguably one of the toughest places in the solar system to visit, right?
Yeah, very.
I remember seeing the temperature swings mentioned. Brutal, like over 430 Celsius on the day side.
Mm-hmm. And then dropping to minus 180 C at night.
Just surviving that is, well, it's a feat of engineering in itself.
It really is. And that's where the European-Japanese DePacolombo mission comes in. It launched back in 2018.
Right.
And it's on this long 7-year cruise phase. It uses gravity assists from Earth, Venus, and Mercury itself. It's finally set to arrive in late 2025.
And its goals are pretty fundamental.
Yeah, very much so. Map the surface in detail, figure out its composition, its internal structure, study its magnetic field.
Okay.
All of this helps us understand how inner planets, like Earth, formed and evolved.
Fascinating. Okay, so moving outwards, the source points to Venus, calls it an uncanny resemblance to Earth.
It does, which makes you wonder what happened there, doesn't it?
Yeah, exactly.
It sparks a lot of curiosity. The magazine mentions the European Venus Express mission that operated until 2014.
Okay.
Gave us some key data, like confirming that double storm system over the South Pole, finding sulfur dioxide high up.
And looking ahead.
Well, ESA is studying a mission called Envision. If it gets selected, it could potentially launch around 2032.
And Vision would look at.
It aimed to understand Venus's active geology, erosion processes, how its super hot, dense atmosphere connects to what's happening on the surface and inside the planet.
And the source mentioned French labs are involved already.
Yeah, 8 French research labs are already involved in the planning.
That international collaboration seems to be a recurring theme here.
Absolutely. You see it again and again. And speaking of big international efforts, the magazine then shifts gears pretty dramatically to Jupiter and its icy moons.
Ah, the Jovian system. The source calls it a miniature solar system.
It really is like one. Which brings us to the European JUICE mission, Jupiter Icy Moons Explorer.
JUICE. Right.
Exactly. JUICE launched in 2022. Scheduled arrival at Jupiter is 2029.
And the focus is those moons, Europa, Ganymede.
That's the core focus, yeah. Callisto, Europa, and Ganymede. Because we suspect they hide these vast oceans of liquid water beneath their icy crusts.
Incredible potential there.
Huge. The plan is for JUICE to spend 3 years orbiting Jupiter, doing flybys of these moons before settling into orbit around Ganymede for really detailed studies.
Ganymede seems particularly special, according to the source.
It does. It's the only moon in the solar system with its own magnetic field. And scientists think its potential subsurface ocean might be trapped between layers of ice, sitting above a rocky mantle and a metal core. It's a really unique structure.
Wow.
It is. And as the source emphasizes, JUICE is just this massive international undertaking. Airbus leads the development, something like 80 European firms involved.
Okay.
And instruments come from over 15 countries: Japan, the US, Canada, Russia, Israel. It's a huge collaboration.
And NASA's doing something similar, too.
Well, the magazine gives a brief mention to NASA's Europa Clipper mission. That one's planned to perform multiple flybys of Europa starting in 2023.
So 2 big missions targeting these potential ocean worlds.
Exactly. Lots of focus there.
Okay, let's talk about Mars. This seems to be the planet that gets the most ink in the source.
Oh, yeah.
And frankly, in space exploration generally.
It's definitely a major focus, and the source details why with several missions. You've got Curiosity, for instance, operating since 2012.
Still going strong.
Still going. Using its ChemCam laser to, zap rocks, analyze their composition, actively searching for organic molecules.
Right. The building blocks.
Exactly. And the source mentions recent detections methane, sulfur-containing organics in places like Glentordan.
Which is precisely what the Mars 2020 mission Perseverance is building on, isn't it?
Mm-hmm. It departed in 2020, landed in Jezero Crater in 2021, carries SuperCam.
The enhanced zapper.
Pretty much, yeah, an enhanced version of ChemCam. But the real game changer with Perseverance is that it's caching samples.
Ah, setting the stage for sample return.
That's the plan. It's a huge step. The source also highlights the InSight mission, which landed in 2018.
The lander focused on the inside of Mars.
Exactly. Its main job is studying the planet's interior using a seismometer called CES. That's a French contribution, actually.
Okay.
It landed late 2018, got carefully covered up early 2019, basically listening for Marsquakes and meteorite impacts.
I remember reading that InSight detected its first seismic signal in April 2019, like hearing the planet breathe.
It's incredible data, really is. But the source also includes the Schiaparelli test lander crash in 2016.
A reminder of how hard landing is.
A stark reminder, yeah. Even as it discusses the second ExoMars mission.
That's the joint European-Russian one.
Right. Departed in 2020 includes a European rover and a Russian platform, specifically designed to drill down, search for deeper signs of life.
The statistics the source pulls out for Mars are pretty eye-opening, too. 48 spacecraft by 2016.
Yeah. And the Opportunity rover stats are just mind-blowing.
14 years operational.
14 years. Covered over 45 kilometers. That's like running a marathon and then some on another planet.
Wow.
And over 217,000 photos online. Plus, the thing where you could send your name on InSight, 827,000 people did.
It shows that public connection Mars has.
It really does. Okay, so moving beyond the planets for a moment. The source talks about asteroids.
Right. Relics and risks, it says.
Good summary. They're seen as both, leftovers from the early solar system and, in some cases, potential future risks.
Like asteroid Bennu. The source mentions the U.S. OSIRIS-REx mission there.
Right. Scientifically interesting because it's a primitive carbonaceous asteroid, has hydrated minerals, might hold clues about the origins of life.
And it might cross Earth's path eventually.
Well, the source points out its potential Earth-crossing orbit, but way off, like late in the 22nd century. Adds another layer of interest, though.
And OSIRIS-REx has that clever sampling method.
Yeah, really neat. Uses a burst of nitrogen gas to stir up the surface material and collect it.
Meanwhile, the Japanese Hayabusa 2 mission visited asteroid Ryugu.
Yes. And it successfully deployed that small French-German lander first, Mascot.
Right, the Scout.
Exactly. It scouted the surface before Hayabusa 2 went down and collected its first samples in February 2019. So 2 missions actively grabbing pieces of these ancient bodies.
Okay, let's turn to the biggest object in our solar system, the Sun. The source highlights that puzzle. Why is the corona so much hotter than the surface?
Yeah, it's that enduring mystery. 3,500 degrees C on the surface versus, what, 1,000,000 degrees in the corona?
Seems backwards.
Completely counterintuitive, and that's what the U.S. Parker Solar Probe is tackling. Launched 2018. It's designed to literally fly through the corona.
Getting closer than anything before.
Way closer. By 2024, it'll get under 6 million kilometers from the surface, measuring the solar wind, ions, electrons, right there in the thick of it.
Wow. Giving us insights into the sun's atmosphere and space weather.
Exactly. How it affects Earth. And then Europe's Solar Orbiter mission, which was set to depart in 2020, is complementary, right?
Oh, so?
Well, it observes the sun from further away, but with really high resolution. It looks at the poles, the hidden side we can't see from Earth.
Different perspective.
Yeah. Helps understand the mechanisms driving the corona and solar wind formation from another angle.
The source also briefly touches on stuff even further out, doesn't it? New Horizons, Gaia, James Webb.
Just briefly, yeah. Mentions New Horizons visiting Ultima Thule, the Gaia mission mapping, 1.7 billion stars in our galaxy.
Incredible numbers.
And the James Webb Space Telescope set to study exoplanets like those in the TRAPPIST-1 system. It just gives you a sense of the sheer scale of what's happening.
It's an incredible amount of activity. Just everywhere. But let's step back for a second. This brings us to that fundamental question the source addresses. Why? Why do we do all this? These missions are incredibly expensive, technically really hard, take years, decades sometimes. What's driving it all?
Well, the magazine lays out several key drivers. First and foremost, obviously, is science.
Okay.
And perhaps surprisingly, a big part of the science is about understanding Earth better.
How does studying, say, Mars help us understand Earth?
Well, the analogy the source uses, which I like, is it's like studying animals to understand the human body. Other planets are like case studies.
Wow.
Francois Forget is quoted giving specific examples. Apparently, testing a climate model on Mars actually improved the accuracy of monsoon modeling here on Earth, for India specifically. Yeah. And studying the complex chlorine chemistry on Venus, that helped scientists understand the ozone hole issue, supported the ban on CFCs.
Okay, those are really tangible links. So it informs our understanding of climate change, volcanology, our own environment.
Absolutely. Then another major scientific driver, the search for life, exobiology.
Right. Mars, with its ancient lakes and rivers, looking for prebiotic chemistry.
Exactly. The building blocks and those icy moons of Jupiter and Saturn Europa, Ganymede, Enceladus.
The ones with potential oceans.
Prime targets because of those suspected subsurface oceans where conditions might just support life.
And then there's the origins question, understanding where we came from.
Delving into the origins of the universe, our solar system. That's why getting samples back from primitive asteroids like Bennu or Mars moons is so important.
Okay, so science is huge. What else?
Technology, technological advancement.
Right.
Robotic exploration pushes the boundaries, forces new solutions.
Some obvious benefits, like GPS maybe, but others less visible.
Exactly. The source mentions the challenge of, say, controlling a rover on Mars when radio signals take minutes to travel back and forth.
Right, the latency.
Or the sheer complexity of designing something like a robot submarine to explore an ocean on Europa. Imagine that.
Yeah, mind-boggling.
And it points to specific examples, like these tiny 10-gram microvalves developed for instruments like the MoMA gas analyzer on ExoMars, finding applications in completely different industries back here on Earth. And of course, computing power. The advances needed for these missions benefit everyone.
Okay, so science, tech, what else is in the mix?
Well, the magazine makes it clear it's not just about science and tech. There are powerful geopolitical and inspirational drivers, too.
Geopolitics.
Yeah.
Like national prestige.
Yeah. Jean-Yves Le Gall is quoted saying, space exploration lets nations affirm their sovereignty through, spectacular firsts.
Makes sense.
And it also engages a public that might be, as he puts it, tired of utility, but is genuinely inspired by those Hollywood dreams of space travel.
That resonates.
Yeah.
You look back at Apollo, the Cold War motivation is undeniable.
Absolutely. Historical context right there. And finally, the source points to a significant emerging driver, resource utilization. Using resources in space.
Okay, and that becomes really relevant when we talk about
the moon. Right.
After Apollo, it felt like we just stopped going for a long time. But now, this source shows it's very much back in the spotlight.
It absolutely is. The source commemorates the 50th anniversary of Apollo 11, reminding us of the scale of that achievement. 650 million people watching.
Incredible.
Astronauts spent over 21 hours on the surface. Eventually, 12 astronauts walked on the moon, brought back 380 kilos of samples.
And the science from those samples was huge, wasn't it? Settling the formation debate, the giant impact theory.
Right. Finding traces of water at the poles, dating rocks, figuring out the mantle composition, discovering the magma ocean.
And French scientists were involved in analyzing those samples, too.
Significant contributions, yeah. And Apollo also validated key tech landings, spacewalks. And then that symbolic Apollo-Soyuz mission in '75 kind of showed a pivot towards cooperation.
So if it was so successful, why the long gap? Why did we leave?
Well, the source touches on that. Cost was a huge factor, obviously, especially with the Vietnam War draining resources. And based on the scientific understanding at the time, the perception was maybe there wasn't enough new science left on the moon to justify those massive human mission costs compared to sending robots elsewhere.
But now there's this massive renewed push. What changed? Why go back?
Several things, really. Scientifically, new analytical techniques have given us a much deeper understanding of lunar formation, its connection to Earth.
Okay.
Also, the far side of the moon, it's seen as this absolutely unique spot for radio astronomy, perfectly shielded from all the radio noise from Earth.
Ah, interesting. And those resources you mentioned earlier.
That's key. A potential game changer. The detection of ice at the lunar poles, confirmed by NASA's LRO in 2009, and finding water and oxygen locked in the regolith, the lunar soil, The significance, the source explains, is huge.
Because you don't have to haul it all from Earth.
Exactly. If you can extract water and oxygen on the moon, you drastically cut the cost of any sustained presence or missions going further out.
Use the water for life support, make rocket fuel.
Yeah, produce fuel via electrolysis, splitting water into hydrogen and oxygen. And even use the regolith itself as building material. That idea of 3D printing lunar structures, it's taken very seriously now.
So the moon becomes less of just a destination and more of a base camp, a staging post.
Precisely. The source frames it as the logical next step, a proving ground for human survival, for autonomy far from Earth, unlike the space station, which is only hours away.
Right.
Learning to live, build, operate independently on the moon. That's essential practice for eventually sending humans to Mars.
And this renewed interest has kicked off what the source calls an international lunar quest. Lots of players involved now.
It really has. China's Change program is particularly prominent. They've orbited, landed rovers, and notably, that first ever landing on the far side with Change 4 in early 2019, specifically to test technologies.
And they have plans for sample return, too.
Oh, yeah. Change 5 aimed for sample return. Change 6 is planned for a South Pole sample return and includes French experiments, actually.
Wow.
And Change 8 aims to test lunar-based tech. China's publicly stated goal is putting a taikonaut on the moon within 20 years.
Serious ambitions. India's Chandrayaan is also mentioned.
Aimed for lunar orbit with a lander and rover, focused on tech development, similar to China's program in some ways.
And we saw that private attempt, too, with Israel's Bereshit.
Right, Space Isle. A high-profile, privately funded attempt early 2019. Unfortunately, it crashed during landing.
Yeah, that was tough to watch.
It was, but it still showed the potential of commercial ventures, and it actually led to an agreement with NASA for future commercial lunar services. So, still progress.
And the U.S. has its own big plans, like NASA's Lunar Orbital Platform Gateway, LOPG.
Yeah, the Gateway concept. Basically, a space station orbiting the moon, been planned since about 2017.
And the idea is it's a staging post for the moon, for Mars.
That's the concept. Using NASA's big SLS rocket and the Orion capsule, the source points out its functions draw on ISS experience, resupply point, maybe processing lunar resources, radiation lab, potential backup base.
And it's international, too. Europe's involved.
Oh, yeah, another big collaboration. Japan's actively involved. Russia signed an initial commitment back in 2017. Canada's developing a robotic arm.
Okay.
And Europe, through ESA, is providing crucial bits like the Orion service modules. The first one was delivered late 2018, and they're studying pressurized modules for the station. France's Space Agency, CNES, the source notes will be part of it.
So with all this incredible planning, all this activity, what are the biggest hurdles still, according to the source?
The challenges are still significant. Funding is, well, it's always an issue, famously summarized as being 20 years away for 50 years.
Right.
Technical complexity is still enormous. Advanced robotics, surviving extreme environments, and just the sheer number of good ideas versus the limited budget. Source mentions only about 1 in 15 mission ideas actually gets funded.
Ouch. But it also seems like the way space exploration is done is changing.
Absolutely. That's a key point. The source highlights the rise of new space. These private sector companies, like SpaceX, developing launch capabilities, technical solutions, potentially lowering costs, significantly lowering costs compared to traditional government programs. The magazine even makes a direct cost comparison between NASA's SLS and SpaceX's BFR concept.
And miniaturization is playing a big role too, right? Nanosats, CubeSats.
It really is. I mean, you don't always need these massive, multi-billion-dollar spacecraft for specific tasks. The source gives that great example of the Marco CubeSats.
The ones that flew with InSight.
Yeah. Flew alongside InSight to Mars, provided real-time confirmation of its landing. Small, relatively cheap satellites demonstrating critical capability. That opens the door for cheaper, maybe more frequent missions.
Okay, so this expanding landscape, more players, new capabilities, it also brings up tricky questions about, well, who gets to do what out there? The source gets into the legal side.
It does, yeah. Quoting Philippe Achilles, the foundation is the 1967 UN Outer Space Treaty.
Okay, what are the key points there?
Peaceful use of space. And critically, celestial bodies are not subject to national appropriation. No country can plant a flag and claim the moon or an asteroid.
For the source points out there's a tension with that now.
There is, because some countries, like the US and Luxembourg, have passed their own national laws. laws explicitly allowing private companies to extract and own resources they get from celestial bodies.
So while the stated goal might be using resources for more exploration.
The source notes other plans are afoot, suggesting commercial profit is definitely also a driver.
Right.
And this raises crucial legal ethical questions. The source really emphasizes the need to develop international law, probably through the UN, to navigate this.
Finding a balance.
Exactly. Balancing commercial interests, environmental protection in space, ensuring long-term sustainability, trying to learn from mistakes made on Earth, hopefully avoid a purely profit-driven kind of, well, race in space.
It sounds like the next few years are going to be particularly exciting, especially when it comes to actually getting pieces of other worlds back here. The source highlights the sample return missions coming up.
Yeah, this decade is definitely sample return heavy. Japan's Hayabusa 2. Bringing back dust from asteroid Ryugu, end of 2020 was the plan.
And the U.S. OSIRIS-REx from asteroid Bennu.
Set for return September 2023.
Okay.
Then there's the Japanese-French MMX mission Martian Moons Exploration.
Targeting Phobos and Deimos.
Right. Scheduled to depart 2024, return 2029. France contributing a mineralogy instrument. Samples from those moons could tell us a lot about how they formed, maybe even about early Mars.
And the big one, Mars samples themselves.
That's the really ambitious NASA ESA Mars sample return mission, aiming for return around 2031.
And that involves Perseverance caching samples now.
It's this multi-step relay race, really. Perseverance caches the samples. A future mission sends a fetch rover to pick them up, transfers them to an ascent vehicle to launch them into Mars orbit.
Wow.
Where another orbiter captures them and brings them all the way back to Earth. Planned landing in Utah.
It really is a relay race across space.
Yeah.
Seeing all those returns laid out
Yeah.
really underscores the long-term vision here.
It shows a deliberate, multi-decade strategy unfolding. Definitely.
So as we wrap up this deep dive into the source material, it's clear that solar system exploration is just incredibly vibrant right now. We've covered this huge range of places: Mercury, Jupiter's moons, Mars, asteroids, the sun itself. We looked at the drivers, science, tech, geopolitics, inspiration, and now resources.
Right.
We saw the strategic refocus on the moon as that stepping stone, the international efforts there. And we touched on the challenges, the rise of new space, the miniaturization, and these critical legal and ethical questions about resources.
Yeah, this magazine issue really offers a comprehensive picture. A field driven by lofty goals, but also practical considerations, global cooperation, but also, increasing competition.
So, given this accelerating pace, all these players, these competing interests, pure science versus commercial profit, national prestige versus international law, how do you think humanity should collectively decide what the next steps are in exploring and maybe utilizing the resources out there? What stands out to you from everything we've discussed today?